Yeah, welcome to the tutorial how to create extensions in fiboa. I would say let's do it the way that you just raise your hands in Zoom if you have questions in between, and then we can discuss them directly. That makes it probably a bit easier than remembering at the end, and then we can't go back to the state where we were. So just raise your hands, and then I'll get back to you whenever there is the opportunity to stop. Cool. So I'll share the screen. And you should see now the repository with the tutorials, right? Good. So we'll today look at this script here, creating a fiboa extension, which will give us give you an introduction of like what the extension will look like, give you step-by-step instructions how to create the repository, how to write it. There will be more probably be covered in the video than we have in the script here, but that's like the baseline of the steps that you need to go through. First of all, of course, there is a list of extensions that is filled automatically with all the extensions that are created in the fiboa organization. If you have an extension that is living outside of the organization, you can open a pull request to this repository and then add it as well. So it's not just restricted to the extensions that we have in the fiboa organizations, but it's open to everyone. The second thing is that there is a list of proposed extensions that we figured could be interesting for the ecosystem. If you have other ideas, just add a new issue here or identify or like assign you to one of these, and you can always take them over and work on them. Exactly, just open a new issue here if there are other ideas as well, so that we know what is interesting to people. So in this session, I'll try to create an extension that is more or less an example. Of course, I tried to find something that seems to somewhat make sense, where the fields that we define are closely related to each other, but also give some kind of a variety of data types and different things that are all, for example, as in date times, we would all have date times only in timestamps extension. And here we have some more things like text, dates, and number of days in different data types. So that is a bit more different than just like having 5 fields that are all timestamps. When I start writing an extension, first of all, I always like try to figure out what are the actual things that should be in there. Are some of these things actually maybe related to other things and should be in separate extensions? Because like extensions should be small and like only cover a very certain use case that is very specific, and should like cover everything, right? So if you have, for example, AI use cases where you need country-related information, provider-related information, and ML-related information, you may want to split them apart into 3 parts, for example, ML AI, provider-specific extension, and maybe the other thing as well should be separate, so that you get like very distinct use cases for the extensions that are clearly separated and that are still small enough to be maintained and agreed upon with the community. So in this example here, I'll call this extension future extension, because the use case is that we provide information about the intended future use of a field. So pretty much the next cycle of planting something. And I've identified that we may do that in 3 different fields here. So the first one could be named next crop type, which is required and is a text. It could be any of those, for example, right? Sugarcane, maize, rice, wheat, or other. Usually that would be a longer list, but for the sake of the example, I've just shortened that to a couple of crop types. that has a description, of course. The second field would be plant date, for example, which is just a date, so year, month, and day. And then that should specify the date when the next crop type is planned to be planted. And then the third field that we want to look at is grow time, which is the number of days. So the rough time until the crop is harvested after it was planted, and that is specified in days. So to specify these fields now or properties in an extension, we first of all, of course, need a repository. So there is a long description here how to use that. We have a template that you can use, and that you can create into a repository very easily. And we'll go through these steps now. So you go, like, for example, into the template repository, which is located at this URL. So github.com/fiboa/extension template. And then in the upper right corner, you use this template button, and then click create a new repository. And then it asks you a couple of things. First of all, you keep the repository template as it is. You want to include all branches so that the CI can also like deploy schemas, etc. And then you set an owner. In this case, I set fiboa, but you can use any organization or user that you're working with. And then you need a repository name. In fiboa, we use now for the name is future extension. So I have this future extension. And generally, just put the dash extension always there so that you clearly identify that the repository is an extension. And then the other thing that we need is a description. And I'll just maybe use this description here. Provides information about the intended future use of the field. And then we want to make it public. You can also start private, but I just start public directly. And then create the repository. It takes a couple of seconds, and then we have a readily set up repository with a lot of files in here that are prepared to be used. And I just see here we should fix the typo here. Anyway, that is all set up for you now, and we can start modifying this. But first of all, of course, we need it locally. So I'll just go to my CLI and then clone the repository to my local machine, and then go into the folder that has been created. And then if we just look at that, we have all the files that we had before in the online repository as well. So now, then last time we saw that there is a command line interface, which is called fiboa CLI. And this can help us to actually rename a couple of things, because in the template, everything is called template, right? So if you look at this again, here it says template extension, and there is template in here and template in here, and everywhere is template. So we need to rename that, and so that you don't need to search and replace manually. There is a tool in the CLI. So what you can do now is to use the CLI, just call fiboa rename extension, and then specify the folder where it is. That is right here, so dot. Then T is the extension name, which is future. We have a prefix for all fields that we want to use, and I just said we will use FTR as a prefix for the fields. So for example, the field that we had, for example, the next crop type would then be called FTR next crop type. S is the repository name, so future extension, and O is the organization that we have in GitHub fiboa. I run that, and then it updates all the files for me to replace the template thingies with these names. We can check that, for example, also here in my, I'll add it to my client here, Git client. That is the other way of doing it rather than in CLI. I'll quickly add the fiboa future extension here so that we can have a look. And then you see here, right, there are a couple of changes made to the files. We can see here, right, future extension instead of extension template. Collection here, there are things renamed. Field prefixes have been renamed. The Parquet file we can't look at has been updated. A couple of changes here in the runners. The README has been updated, etc. So that's our first thing. We can directly commit here. So renamed all the files. Great, first step done. So now we've pretty much set up the repository, and now we can start writing the extension. Looking at the repository, yeah, we see here now the future extension, etc. There are a couple of files. The main important ones are readme.md, which is the written specification here, right? That's this file. Then there is the schema file, schema.yaml, which is written according to the fiboa schema language, let's say, which is a JSON schema inspired schema language for fiboa. And then the third file is the third set of files are the examples here, which is a GeoJSON folder and a GeoParquet folder, which have example files in here that we can use to just like show how the extension is meant to work. So looking at the files, the first one we want to update is the readme.md. So I'll open this up here in Visual Studio Code so that we can work on that. Where is my future extension add? Yep, trusting it as well. So we can now see it here and open the readme.md. First thing we want to do is to set the extension maturity classification to proposal because it's brand new. I want to add my GitHub handle here so that people know which person to contact when there are questions, right? So that is m-mohr for me. And then the description that I had before for the repository I also put here so that people can read what the extension is about. Here's a list of links that people can click, but the first thing that we want to do now is to actually update the properties here and describe them, how the fields work. So the first property that we had was next crop type, right? We had this table here with the fields, and we'll now copy that over to the README here. So the first field is meant to be FTR next crop type, and we said that it's a string, so that's already correct. We also want to require it, let's say, and then the text could be something like the crop type that is planned to be planted, and it is meant to be one of sugarcane, maize, rice, wheat, or other. So that's our first field. And then we had the other one that was called plant date. And that is a date we said. Oh, and by the way, the types that we define here are all coming from fiboa schema. And the data types we want to look at, well, that doesn't look overly well. Let's look at here. Are defined in a file here that you can, let me quickly put a link in the chat. So that's defined here in github.com/fiboa/schema. And there are two files in the repository which describe how to define schemas. So the schema language is described here, right? That is based on JSON schema pretty much. So it's all the same things here. The only difference is a type field, which has different data types because JSON types are relatively restricted and not really applied to, for example, GeoParquet. And the data types we're choosing are coming from this list here. There are a couple of integer data types, floats, strings, arrays, object, date time, geometry, bounding box. And those are the ones we choose from now when we're selecting the types. And for this, for example, we want the date here, the date type, because we only have year, month, and day. Exactly. So we have the date in here. Now we need a description. Oh, that is a little wrong here. Let's move those windows away. We have a date here and then a description. We also add here, for example, the date when the next crop type is planned to be planted. And then we need yet another column here that will be FTR grow time. And that data type will be, for example, right? So let's think about that. This is a number of days. So a number of days can never be or must be always greater than 0. I guess there are no plants that grow up in like in 0 days or less. So the first restriction here is that the day must be greater than 0. And then usually like we have 2 data types in the table that we just seen, right? So there is int8, for example, that we could use, uint8, int16, uint16. But we already said it should be greater than 0, so we can use an unsigned integer. So we use either uint8 or uint16. 255 days might be a little low. So I think I'll go with uint16 just to make sure. That's, I think, roughly 17 or 18 years. I don't know. Math on stream is never good. I think 17 years or something like that. So that should be good enough for our growing seasons, I think. So I'll take that as a data type here. So that is chosen, uint16. And then we still need a description, of course. So this time I'll take this description here, the rough number of days until the crop is meant to be harvested. And we say that it must be greater than 0. So this is our first description of the fields or the properties that we have. Likely the CI will later complain about the indentation of the table here. It does a bit of markdown checking. So quickly like align those so that they look good. And that should be it. So that's the README. What we can do now as well is there are a couple of scripts that you can run in the repository to make sure that everything looks good. So we've saved the file, and then there is a couple of pipenv scripts that we can run. What you need to do first is once you need to install the pipenv to your Python environment. You can do like that, pip install pipenv ---- user. And then whenever you are in the folder that you're looking at, so your future extension, you can run scripts like pipenv run test docs, for example, that checks the markdown files. And if you run that, it will either complain about something that's wrong or just exit and tell me, well, everything's working. The first time you run this, it may take a while, then it like installs the dependencies that it needs. But yeah, so that's done. And again, yeah, so that succeeds. Everything's looking good. We can commit the README, or could commit the README with our changes that we see here to the repository. The next thing that we need to do is to update the schema file. So there is this schema file, and that doesn't look quite right yet. This line always stays as it is. That's just the reference to which schema version we're using. And then you define first the required fields and then the properties in a schematic way so that it can read them for validation, for example. So the only field that we set to be required, right? So we have here one required, that is next crop type. So I'll set this field to be required here. That's it. And then we need 3 properties. So first of all, we have next crop type, copying that over. And then we need to define the schema. So the first thing that we have, of course, is type is string. We copy that over. And then, of course, we said this can be one of sugarcane, maize, rice, wheat, and other. So we'll create an enum for that so that it can validate whether that is one of these specific values, right? Enum double colon and then a list of values in YAML. Then the next field is plant date, and that's of type date. Plant date, type date. There's not a lot to be done here. We just copy the field name and then set the type to date. And the third field is FTR growth time. It's uint 16 and must be greater than 0. As it's an integer, you can say, first of all, from next line, FTR row time type is uint 16. And then we said greater than 0, so it's an integer, so we can say minimum is 1. That's our schema. You can save it. And the next step we can do is to actually also check whether the schema is correct. So there is another script for that, which is called pipenv run best schema. And then it will tell us, yep, this is valid. So that's good. So schema is done as well. Now we need to get to the examples. Actually, I'm just wondering, no, I don't see any raised hands, so I'll continue. There is GeoJSON examples here and GeoParquet examples. Working on extensions here, it's easy, of course, to adapt JSON examples, so I start with that. And then from the JSON examples, we can create a Parquet file. So I'll look into this. There is already like a polygon in there. I don't want to update that right now. I just look at the properties here and want to add things that we define. So for example, we have 3 fields, right? We have FTR next crop type, plant date, and grow time. We can add them here and then put values in here. For example, for crop type maize, for the plant date, we can set, I don't know, that is 10th of March, May, that should be planted. And then the grow time is, I don't know, 123 days. Right, that is might be roughly correct. I'm not sure. So that's already what we need here. The other thing that we need to check is the collection. There is collection metadata, and we need to check whether the future extension is actually marked to be implemented here, and that's the case. So that's it pretty much. And the next step again is to check whether what we did is correct, right? So we can just run pipenv run test GeoJSON in this part. And that checks a couple of things and says it's valid. We can try whether that also like really works what we did. And like, for example, put in here, like just add a space after maize. And let's see whether that still validates. Running it again. Oh yeah, now it reports an error that the enum in schema requires to be one of these values, and FTR next crop type in our case, and the properties member is maize with a space. So we'll remove that again, of course. Okay, so the GeoJSON is now valid. Now we want to create or update the GeoParquet file to also include this. So the next step is to just run in the CLI again, pipenv run create GeoParquet. And that takes the GeoJSON and creates a GeoParquet from that. Right, so now we can use what we learned in the last session with the fiboa CLI and look at the GeoParquet file as well. That is fiboa describe, and then the example that's in examples, GeoParquet, and then example parquet. Let's see how that looks. Oh, I mistyped describe. And then we see an overview of what the file looks like, right? We see here the future extension is implemented in the Parquet file. We have these columns, right? Determination date time, that was already in the example. FTR grow time, which is uint 16. Next crop type, which is string, and not null because it's required. And then plant date is the date with the granularity of day. geometry for the polygon and ID. Here's an example, like here's all the data that we put into the Parquet file, the GeoJSON file, and that is also now available in the GeoParquet file. So that looks all good. The next step, of course, is to check whether this is all valid again. So pip and run test GeoParquet also to check the GeoParquet example. That is also valid. So we are pretty much set here and can commit everything that we did to the repository again. So we created schema, read, me, and examples. Commit. So that's now all available in the repository. You can have a look as well. Let's see that wrong window. Let's go here, github.com/future extension. And there is our content. So the last step that we now need to do is to release the extension to the public. The first step here is to update the changelog and say what we did. Because we're lucky guys in this case, we just have the first release, so there are like no real changes, let's say. We can just say, this is version 0.10, released it on the 29th of April, and this is our first release. So done. Yeah, and then the next steps would be, of course, to let people discuss your extension, inform them via chat, email, fiboa, Slack, or whatever, get some consensus on the fields, and then once that's done, you will eventually release the extension via GitHub releases. And this will automatically also publish the schemas. So what we do for that, we go to the repository, right? I still need to, of course, update the changelog that I just updated. Update changelog, commit. And then I'll copy the text from here for the release. I go to the GitHub repository again, and then here under releases, there is a button, create a new release. I click that, and then the version that we chose is 0.10. I'll put that here at the top. Then as a release title, I'll also put v0.10, and then put here the release notes for the from the changelog pretty much. And then I can just publish it. This will now trigger a CI run, which publishes the schema. So this means in the end that the schema that is like in this GitHub repository here, the schema YAML, will be published to this place here where the schema identifier lives. So fiboa.github.io future extension version 0.10, and then schema YAML, right? And that will be updated every time we do a new release. There will be then future extension v0.2.0 or something like that. And this is used in the end in the places where the extension is used so that the validator can pick it up, validate the data, etc. And once we wait a couple of seconds, right, this is still pending here. That's the CI button. We can also look at in the actions part here, right? It tells us that this is still running. Now it has been both succeeded, both CI runs were successful. And I believe we should now be able to click this button here. Oh yeah, it downloaded us the file to the local disk. So that is all working. Yeah, now we have published our extension. The only thing, of course, that is missing is that we should add it to the list of extensions. So there is a list of extensions here, github.com/fiboa/extensions. It's not here yet, and it will only pick that up if we change the repository bit. Here in the repository, there is an about section with a gear icon. And we want to have the topic extensions here in here so that it can actually like identify this as an extension repository. We save the changes. And then the next night, this list will be recreated and then the extension will show up here. So this takes a couple of hours until midnight, and then it will run again and update this. And that's pretty much the way to create an extension. If you want to change something, of course, you go through the last steps that we did again. You may update the README MD, you may update the schema file, you may update the examples. And then you need to do something like a search and replace in your code editor through the files and replace, for example, v0.1.0 with v0.2.0 or at some point v1.0.0. And then or commit these changes all again, and then you can release again as we did before. Exactly. And that is how extensions are created. And then everyone can pretty much use this identifier here, copy that into their collection metadata, and implement these fields as we did before in the examples, right? So they could add these fields. They would need to add this field because it's required, and may optionally add these two to their data, or also in the geoparquet file. They can validate against them. They can use them for working with the data, and as more of the data sets to implement these extensions, that makes it, of course, more interoperable because you can compare the data sets. You can work across multiple data sets with the same field names, with the same semantics, so that, for example, the grow time is in days, because some others may want to specify that in years or in hours or whatever. But here it's now clearly specified, it must be in days, so all the data will comply to that if they implement the extension, and then you can be sure it's always in days. Similarly for the crop type, right? If they have different values for the crop types or for the plant dates, use not date, but I don't know, seconds since 1970, which is the Unix date time, then of course it all makes interoperability difficult. And this helps to standardize the data. Yeah, I think that's pretty much it. And now I would open the floor for any other questions that are there. Yeah. Is there still anyone?
Hi, Matthias. That was really clear. Thank you.
Hi, Dave.
One question would be, do you see circumstances in which a particular schema should be not enforced, at least strongly recommended based on elements of the core schema?
Probably, yeah. At least in Stack, we have that where we're relatively sure that 90% of the use cases would have that, but maybe 10 don't. But it's for a specific use case very good to have this information. So sometimes instead of doing the requirement that it must be there, we go, well, it's strongly recommended, right? That guides the user a bit with best practices, let's say, how to go forward. So yeah, this is not really enforced. I think we could actually do that with the schemas to have something like recommended true instead of required, and then tell people to, or give notice in the validator if that's missing. That's not there yet, but that could be indeed an interesting idea to have, because here we have this language that is not JSON schema, so we could add additional properties if we want. Yeah. Any specific use case in mind there? Right.
Oh, okay. So, for example, I'm imagining that the extensions for machine learning and so on are only going to be relevant if you've got the determination type as automatic
Yeah.
from Earth observation or something like that.
Yeah. That is correct. Yeah. I'll quickly take a note to write down this recommendation thing. Otherwise, if there are any other questions, let me know.
I've got another one, but happy to let someone else go if there's anyone. So do we have anything, or have you considered having anything in the core for saying like what the boundary represents? Because I'm seeing here you've got this example where we're talking about like a crop type, and for the UK like legal definition of a field, it's going to have multiple crop zones in there. So I think maybe having it very clear what sort of boundary a data set represents could be quite valuable when you're thinking about, particularly with what sort of validation do you want to apply.
Yeah, I guess that is a good use case for an extension, right? I mean, we're just starting, so
Oh,
there
sure, yeah.
things need to evolve. We only have this like determination things in the core spec, but otherwise, I think pretty much everything needs to evolve in extensions right now. But yeah, for specific use cases, I mean, you know how to do extensions, so you can just go ahead and create one, of course.
Of course.
And yeah, but yeah, I think that is to be done pretty much. Sounds important enough to have soon, I think. Yeah.
Great. Thank you.
Welcome. Cool. I think as like the attendance is relatively low, we can pretty much close here.